Okay, so let's get right into it. We're tackling a huge topic today, the digital brain. We're going to explore what all this screen time is actually doing to our kids' brains.
This is the question that's on pretty much every parent's mind, right? And teachers too. I mean, we're all wondering about it. Forget the arguments about phones at the dinner table for a second. What is actually happening inside their heads on a brain level?
Well, it turns out that nagging feeling, you know the one, it's not just in your head. The science is finally catching up. We now have neuroimaging that gives us hard proof of what so many of us have been suspecting for years.
So, let's start right there, with that feeling. Because it's not just a hunch anymore. The data is showing us that there are visible, physical changes happening in our kids' brains. And this is where it gets really fascinating, and maybe a little startling. Researchers have found that when a neurotypical kid, a child with what we'd consider standard brain development, doesn't get enough of that complex real-world experience, their brain can actually start to function in ways that look a lot like a neurodivergent brain, like a child with ADHD. It's wild, right? It shows how the environment can directly shape biology. So what does that actually look like? I mean, how are these digital worlds physically reshaping the connections inside a developing brain?
Okay, so here's the big difference the brain scans are showing us. When kids spend time in rich, three-dimensional environments, playing outside, building things, interacting face-to-face, they develop these super intricate and complex connections in their frontal lobe. That's the part of the brain that does all the heavy lifting, the higher-level thinking. But on the flip side, kids who spend hours and hours just consuming digital content, their brain connections are, they're just not as strong. They're less robust.
And listen, this isn't something that just kicks in when they're teenagers. We're talking early. MRI scans are showing changes in the gray matter. That's the brain's processing center, in kids as young as 3 to 5 years old. And these changes are happening in the exact areas that control language, reading, even empathy. And here's the really crucial takeaway from all this. These functional differences in the brain's wiring, they can become permanent, structural changes if the environment doesn't change. And this is happening completely outside of any formal diagnosis. It's not about a pre-existing condition. It's a direct response to the world they're growing up in.
All right, so we've seen the scans, we've heard the theory, but what about the hard numbers? Let's take a look at the data. We can actually track these changes over a 40-year span by zeroing in on one really critical cognitive skill.
And that skill is working memory. You could think of it as your brain's mental sticky node or its RAM. It's what you use for decision-making, reasoning, controlling your behavior. It's absolutely fundamental to how we think.
So how do we measure this? Well, we use the gold standard in neuropsychology, the Wechsler Adult Intelligence Scale, or WAIS. And because this test has been around for decades, we have this incredible, reliable set of data that lets us see trends over a really long time.
Okay, so check this out. Back in 1981, the normal raw score for working memory in 18 to 19-year-olds was a 14. Now fast forward to 2024. After decades of screens becoming more and more a part of our lives, that score has dropped. The new normalized score is 12.
Just let that sink in for a second. A 2-point drop. Now, I know 2 points might not sound like a lot, but in a massive population-wide cognitive test like this, a 2-point decline over 40-some years it's a really big deal. It's a significant shift.
And if that's not concerning enough, the very neuropsychologists who study this stuff are raising a red flag. They're saying that based on the patients they're seeing every day, this downward trend isn't just continuing, it seems to be speeding up.
Okay, I know that all sounds pretty intense, maybe even a little scary, but the goal here isn't to freak everyone out. The whole point of knowing this stuff is so we can do something about it. So let's shift gears and talk about how we can get these developing brains back on the right track.
Because here's the good news, and it's really good news. The brain is incredibly plastic. It can change. These trends aren't set in stone. Now that we have this information, we actually have the power to step in and reverse what's happening. So what does that path forward look like? Well, first, it's about knowing that intervention actually works. This data isn't just about confirming a gut feeling. It's about giving us the scientific backing we need to confidently make some changes. And really, it boils down to 2 simple steps. First, we need to understand the why, that a lack of real-world, hands-on experience is holding back some critical skills. And second, we have to act on the how. And look, this doesn't have to be some monumental, complicated thing. It can be as simple as swapping 1 hour of tablet time for an hour of building with Legos, or taking a walk outside, or even just cooking dinner together. It's those messy, multisensory, real-world activities that build the strong brain connections we've been talking about. And that brings us to the big final question. This one goes way beyond just our own homes or classrooms. It's really a challenge for all of us. How can we, as a whole society, start to redesign our world, our schools, our communities, our public spaces, to build better, stronger, more connected brains for the next generation?